Okay, yesterday we stopped at the sixth equation that derived from these three Newton equations. We are now in the projectile subchapter. Projectile means you throw something into the air and then it drop down under the effect of gravity. Okay, so we have derived the sixth equation to solve projectile question. So original from these three equations, and then you work for x direction where your acceleration x is 0. Then the second set equation where your g is negative g because direction is going down, negative g. Right? Okay, so any question on the text equation? Okay, right. Oh, I need to give you there's a new set of tutorial question. The one that I give you is version 1. Actually, there is a version 2. So I already update into the island already. And yesterday, I give you the Appendix B and Appendix C. One is for the vector, one is for the chain rules, chain rules calculation. Okay, let's look at this example with this application of the projectile equation. So you have a sack slide off the ramp with a horizontal velocity of 12 meters per second. If the height of the ramp is 6 meters from the floor, determine the time needed for the sack to strike the floor and the range R where sack began to power out. So this question, you need to determine the distance and the time where it reached the ground. Okay. So how you know that you are actually answering the projectile question? How you know? Usually, you will see something slide, the word slide, and then give you a height of something. So these are the two main keywords where you know that is under projectile chapter or projectile section. Okay, so something fall means it's in the projectile motion. It's falling down in a curvature motion. So first, you start with your origin, with it at the end of the slider, and then you need to draw your axis. Your axis to the right is x-axis, going up is y, and your origin is at here, at the end of the slider, which is your O. And the vector of velocity is horizontal. You mentioned there already. You give you a horizontal vector. Velocity is to the x direction. Okay. And you're given the height of the floor is 6 meters. So for dynamic question, you need to imagine the motion. So if something slide off by the end, what will be the motion? We go straight line? No, right? So it will slide and then go to the curvature motion, a curve like this. So what you do, you draw a curve and the expected motion, something like this, right? So you slide down and this, and you know that the only effect of this is gravitational force, which is going down. Okay, so remember your G is going down. So you draw your axis, you draw your object, then you draw all the information you know, including the A or velocity that you know. These are the steps before you start answering. Okay, draw your object, draw the axis. Where does it start? Where does it go? And then put in the velocity and acceleration, the direction. Put in the arrow. Okay. Next, once you have all the information, you need to find the distance of R. So before answering, you need to know what actually you're going to solve. If you do not know what to solve, then you don't know what equation to use or what you're going to find. So you're going to find the R, or you can label anything that represents range the end of the tip to the object fall. And you need to find the time to fall from 6 meters to the ground. Okay, so you just label, in this case, I label the end of the slider is A. And then the location where it hit the ground is B. Okay, then the horizontal position to the ground is C. So I have 3 points, point A, point B, point C. And from here, I can define my A to C is 6 meters. And R, or the distance, is C to B, or B to C. So what different from the static is, from here, you need to include the motion. Include the motion, it is the green arrow and the red arrow. Okay, we start solving. Again, from your answer sheet, break into half. Left-hand side, you do x-axis. Right-hand side, you do y-axis. So we start with the horizontal motion, which is the x-axis. So x-axis, acceleration is 0. AOX is 0. So you can either memorize or you can derive from the 3 equations there. Okay. So recall, when we put in AOX equals 0, we arrive at AX equal to OX. Okay, this one a bit fast, huh? So how to arrive this one? You look back at the yesterday class PowerPoint slides. But once we put in the AOX equals 0, we arrive at VX equal to VOX. Okay, the second one is when you put in AOX equals 0, you arrive at XO or S equal to SO plus VOXT. Okay, and the last one, the last equation, which is V square equal to VO square plus 2AS. That one, when you put in AOX equal 0, you get VX equal to VOX. Yeah? So you get these 3 for the horizontal motion. Understand? Okay. I recap. Just in case you forget, I go back yesterday's slides. Okay, yesterday's slides, we established 3 equations. We use 3, and then we go for horizontal motion, where we put in A or X equals 0, where your AX here, you put in 0, 0, 0. And this one you change to x, change to x, change to x direction, x direction, x direction, x direction, x direction. T don't have direction. So you modify this set of equation with this put inside here. You arrive at 3 new equations. These 3 new equations. This is for horizontal. Okay. Then the vertical, you apply y-ax acceleration going down because it's negative, because you already define going up is positive. So you substitute minus g inside these 3 equations. And once you substitute there, modify all this into v sub y, and all the unknown become sub y. Voy, Sy equal to Soy, and so on. Okay, just need to be careful is you are substituting negative, so you are removing the positive sign already. For example, the first one you get Voy minus GT. Second one also minus GT. And the third one also you get minus 2G and not positive. So we're actually applying the same concept with this case. So no matter what kind of question you see is a projectile, something falling from a height, you divide your answer sheet into left and right. Left hand side you do x-axis, right hand side you do y-axis. So you can derive from the 3 equation, and then you write horizontal motion. You arrive at these 3 equations. Okay, once you arrive at these 3 equations, you start looking back at your drawing, at your free body diagram. So you know that you are given, this is your starting point. And you're given your starting point, go to the right, Vx equal to 12 meter per second. So you put in Vx equal to Vax equal to 12 meter per second. This is the first information you have from the question. You substitute inside there, right? So you solve the first one already. Your Vox you know already. Second one, x, this one, x equal to xo plus Voxt. You're actually finding the r, right? And you're looking at the x position. It is here. You're finding the distance from here to here. This one. This is your x direction. So this is your x. X is here, right? So maybe I draw something. Okay. So if you extend this axis, so this is 0. This is maybe this is xo. This is x1. And then extend now, this is x1. This is xo. So the r is actually this difference between x1 and xo. You see this one as Cartesian problems. All right. So that's why I replace straight away. I replace r as my distance that I need to find, equal to xa. Xo is here. It's my position of my. You can put this one as xox or xa because I label this one is xa. So this is xox equal to vox means it's the starting point of a. Here, go here, and the time. You just modify this equation according to your scenario. Yeah. Okay. Next, you substitute the value. You know your Vx is 12. You substitute inside there. So you have arrived at a new equation with 2 unknown with the r and xa. You don't know the distance of xa. You know actually is the starting point, right? Starting point. But you remain that because we need that for substitution later. Okay. So you put in the value there. Next, we move to, once establish the general equation, the 3 equation for x direction, you move to the right hand side of your answer sheet, which is you do vertical motion. Vertical motion, you recall, you substitute your AC equal to -3, you arrive at the 3 new equation. Just remember, positive become negative already. Okay, and you substitute the value that you know. So here, the first one, Vy equal to Voy. What is your Voy? Here. What is your velocity going up? Y -6. Okay. You see this one as object, and you're given velocity 12 meter per second. All right. This is x direction, right? This is y direction, right? So you have this one equal Vx, right? Now you substitute for the y component. What is your Vy? How come don't know? 0 lah. There's no Vy lah. Because your V is totally 100% x-axis. Unless there's an angle there. Then you do trigonometry, sine and cos, that one. So this one is straight 0 degree to x direction. So your Vy you know is 0. It's a free mark. You write Vy, Voy equals 0, got marks one. Means here, going down 0. Yeah? A lot of hidden information here. Okay, that's why I skipped the first one. Then I go to the second one. So second one is y direction. Y, you're looking at this direction. Y equal to yo plus voyt plus -1/2 gt squared. Again, your opposite direction is going up. This is 0. You look this one as Cartesian coordinate. This one 0. What is your YB? What is your YB? You see this one as Cartesian. What is your YB? This is 0. So you know that the object at here. What is your YB? This is your YB. Answer is -6, not +6. So you know your YB already. YB -6. You have to know your direction. It's not like static anymore. It's dynamic. So it's vector with direction. And going up positive. So go down is negative. YB negative. YA 0. Because your starting point 0. VAY. VAY. You look at the information you have. What is VAY? 0. Because this is straight x direction. 100%. So VAY 0. G you have. Right? Okay. So here you also have. So you also have. Okay. So -6, 0, 0, and then 9.81. So here, you actually can find t already. There's only one unknown in this equation. So it's good habit you put in, after the equation, you put in equation 1, equation 2, equation 3, equation 4, equation 5. Then from there, when you want to find something, you just refer or from equation what, and you do from there. Okay. So here you can find 1.1, and again, this one is a square, so you have a square root, or you have two solutions, but time you don't have negative time, you only have positive time. So get the positive value. Time is 1.1 second. So in this module, again, 2 decimal place minimum. Okay, any question for this one? No, So then I go back. to the first one. The first one there, r equal to xa plus 12t. Now you have the t, you substitute back, you find the r. R is 13.3 something. Okay, again, 2 decimal place, although on my slide is 1 decimal place. Right, final answer always give me the unit. In calculation, you can skip the unit in your working for your solution. You don't need to put in the unit, but final answer, you need to give me the unit. So this is how you find the R. Okay, so this is how you solve it for projectile question. Okay, the step always start with diagram. Put in the axis, put in the motion, which is the velocity and acceleration. Direction, put in the arrow there. After you have the diagram, you can estimate the motion, how the object will move under gravitational. Then call out the 3 Newton equation. Okay, call out 3 Newton equation. And then substitute x direction, a ox equals 0. Build a new equation. For y direction, your AOC or AC equal to minus G. Yeah. No, you don't need to know which one, as long as you build the 6 new equation from this from the 3 Newton equation. It's fixed already, the step fixed already. Every time you do the same. You don't need to look at the question every time you see projectile question. What you do, you write these 3 equations. And then first step is to derive the 3. You put in ax equals 0. Substitute here, get these 3 equations. Next steps, you substitute ay equals minus g. Get 3 new equations from here. After you have these 6, look at the question, what information you have. You find which equation that information you have. You will solve. Like for example, just now. Like for example, just now, you substitute one of the equation, you get the time already. And then you need to be smart enough to choose what equation to solve. But the hints that every time you will have 6 equations, you're able to solve 1 equation first with the given information. Okay, now for example, this one. So you build the 6, and then suddenly from here, when you substitute the known value, you can solve 1 unknown. Once you solve unknown, then you go back to another balance of 5 equations. Then you see which one I can substitute this one in to solve another unknown. And then from there, you can work back lah. Yeah. Okay, so from here, actually, the question can continue to ask you, what is the velocity before it hit the ground? With this, you find the Vy and Vx. This one. Vy and Vx, and then you find the resultant, you find the angle, and so on. Yeah. Okay, I think we spend a lot of time explaining this one. Okay, the next one. This one is more on the final exam standard. So you use a chipping machine, whereas some of you don't know what is chipping machine. It's quite common in overseas. Means you break the branches into a shredded wooden pieces lah. Okay, so you are given a machine, and it was designed to eject a chip at a 75 meter per second. So this one can be a design question. Can be a design question for your aerodynamics or your FYP or something. If the tube is oriented 30 degrees from horizon, mean this one, the nose you rotate 30 degrees, so there is an angle of projectile. Okay. Determine how high the H chip strike the pile if there's an instant, at the instant, they landed a power 6 meter on the tube too. This one is the combination of two questions. You solve projectile from the machine, and you solve the projectile on the pile that on the ground. It's actually two problems. And then you solve the equation. Yeah. So one scenario will give you 3 equations. One scenario will give you one equation give you 6 equations. One scenario give you 6 equations. So you should be able to solve. Yeah? So if you look at the tutorial question, you're given the distance between the machine and the pile, or your objective is 6 meters. Meaning you can see this one, this problem as if you throw a stone and it hit the target 6 meters ahead. Okay, and you're given a height just now, and you need to find the height. Just now height is given. Now you need to find the height. Okay. Height in this case is not given. The length is given. They're given, right? Is it? Oh, okay. I give you the height from the machine. The question asks you the height of the pile. It's two questions here, two problems here. One is the machine problem and the wood pile problem. It's a combination of two problems, so you need to solve using projectile equation. All right, so you need to shoot something from 1.2 meter, hit, and then you need to find the height. Okay. So you set up all the dimension. Yeah, we agree that we all positive value. So 1.2 from the ground. Your starting point is 1.2 above the ground. So your starting point is here. So you know that your h is actually, you find from the distance here. Take this distance minus this one, you get the h. Okay, you need to find the projectile of wood pile. You see the curvature, hit point A. So you have the range, and you have the curve. You know the time when it hit here. So you can find when it hit here, then you can do the remaining one. Okay. Okay, now your projectile at 30 degrees. This is a vector with an angle. So you can split this one into x and y. You can split into x and y. Your x-axis is cos, your y-axis is sine. So your VOX is VOX cos theta, which is cos 30 degree. VOY equal to VO sine 30 degree. This one you have to know already. Okay. See this one as 2-dimension question, x dimension and y dimension. Okay, the pile was thrown at a certain degree. So first you break the known vector into x and y. Or even you don't know, you just write VOX and VOY, just in case you don't know. Just that you show that you actually understand, oh, I need to break the vector into x direction and y direction. Okay. Once you do that, you use mathematics to find the magnitude of that vector. Okay, this one I skip. This one very fast. Okay, you know the direction. One is horizontal, one is vertical. Okay. Then VAX, it is here, equal to VOX. This one I go very fast. I assume you already can establish the 6th equation already. From the 3 Newton equation, you substitute AOX equals 0, you get 3 equation, and then another set, you substitute AOY equal to -G. Okay, So the first one, AOX. Yeah, hold on. I think I need to call something else. Okay. Okay. Yeah. So these three Newton equation, this term is the second position velocity. This one is initial velocity. Yeah. The one that on the left equation is the results. Then you see the one is initial. Yeah. So meaning all the equation that you derive, which is on the left hand side, is your result. It's where that's it for, or at the second position, what is the velocity, what is the distance, and so on. This one you have to have the general concept. That's why when I substitute just now, I know what I'm finding. Okay. So this one I go a bit fast. So from here, I know from the first equation in horizontal axis motion. First, I know AOX. I know that AOX equal to 6.5 from this trigonometry equation. And the direction is going there, going to the right. And remember, label your acceleration is going down. And the magnitude is equal to G, equal to 9.81. So here I write AY equal to minus 9.81 because it's going down, because our general axis going up is positive. So once we have all the information, you put inside your diagram. Okay. Who still don't understand why I can write VAX equal to 6.5? Who still don't understand how I get this one? From where I get this one? From this equation, from this equation. Okay, from this equation, from this equation, this one, again, this one, all the equation on the left, the parameter on the left is the end result that I want to find. Okay. Okay. Now we look at two dimension. One is horizontal, one is vertical motion. Recall again these three equations that you derive. When AOX equals 0, you get these three new equation. You look at the diagram, whatever that you can use, you use substitute, and then you find the answer. For example, VOX equal to VOX, you know VAX already. You know VOX already. You already find, so substitute here. Here also same. Then this one, AOX in X direction, you know the distance, right? It's 6. So 6 is here, positive, because it's moving to the right. If the question, I flip the question, I give you the X and Y the same, but I swing my mouth to the back. I throw to the back, then my X will be negative. No, means I throw my chip to the back. But it doesn't make sense. Okay. Okay, so from the first one, from the second equation, I substitute XA equal to 6. XO, you know 0, because origin you start from 0. VOX, you know, VOX you from the trigonometry calculation. VO cos 30, you already find 6.5, and TOA. So TOA, you know the time. Okay, in meaning the object move from here to here, it takes 0.9 seconds. Once you find the time, you can go to the next one, the vertical motion, and find the another 3 equation and substitute inside there, right? So recall these 3 equation from the vertical one. When you substitute AC equal to minus G, you get these 3 equation. So because we have the time already, we have the G, we have VOY, we know VOY here. So substitute inside there. Okay. Now we ignore this part first. So substitute VOY 0. VOY you calculate from here. T you know from the previous one. G you know, and then T you know. And then this side a bit tricky. YA is here. In this case, I take H minus 1.2 Y. Why I take H minus 1.2? Or if you take 1.2 minus H also can. But my case, why I put H minus 1.2? Why? What assumption I have if I put bracket H minus 1.2? What assumption? I assume when the pile hit here, my pile is already higher than 1.2. Yeah. If you use this diagram, then this diagram, my H is lower than 1.2, right? But in my calculation, I assume my H is higher than 1.2. Okay. So you find your H is 0.483. Which one? Y? YO? What is YO? YO is here. YO is 1.2. Okay. So here my YO you cannot put 1.2 because your starting point is 0 here. If you put 1.2, meaning your if you put 1.2, meaning your axis starting point is 1.2 here. It's not from the mouth here. If you put 1.2, it means at the top of the mouth starting point is 0. O means your starting point, your reference point. Where do you start? It can be, you can assume it's always 0, but it's not necessarily always 0. Okay, so you can always, you can use the first equation also, where you use Vy equal to Voy minus Gt, right, and so on. Okay, so projectile question, you can go online and look at other questions. So this is how you apply. Basically, the step will be, you need these 3 equations. Basically, you build these 3 equations. Once you answer, you have these 3 equations. Let's say the question is 20 marks. If you write these 6 equations, usually you have 5 marks already. You write these 3 equations, you derive y-axis, x-axis component equation. There it will give you 4 to 5 marks already. And then you give the diagram with the starting point, the x and y, and then the given information. Sometimes you're given the last one, and then you work back the equation. But basically, these 3 equations already give you 3 to become 6 equation is enough to solve for all the unknown already. Yeah. So basically that is the part lah. Huh? Okay, we continue with a new slides. Huh? Okay, we'll move to second part of the chapter 1. Second part already, huh? We continue with curvilinear, but we now break into tangent and motion, tangent and normal direction. Yeah. Now, just now, what you learned is curvature motion with the x and y, but now we look into dimension of normal and tangent direction. All right. Now, we start something a bit newer. Just now, what you learn is in the x and y direction. X and y direction is outside the object system. Meaning, if I focus on this this pointer, just now your x and y is here. Yeah. But if we, and then now what we want to focus on is on the object. When you focus on an object, we use different system where we use normal and tangent axis. Yeah. So I need you to flip your channel a bit. So meaning what you learned before this is outside axis, outside the object, which is x and y, with global axis. If you use any software, you know your global x and y, right? So like your Google Map, you have north and west and south. But now, when we go into 1.6 subsection, we look at the object. When the object moves in a curvature motion or any motion, we will use different axes we call normal and tangent axis. Yeah? Okay. Now, let's say we have an object move in a curve point, curve motion, and then you label the axis. If the object go perpendicular to the curve, or normally it's your velocity vector, you label as tangent direction. And you know that every curve, like your palm, just yesterday I mentioned, the palm, if the curve is going up, the direction of your palm is facing inside the curve. That one will become your normal direction. Okay, now normal direction is always pointing to the center of the curve, which is we label as O. All the curve have one center of curve, or you can see it as circle. Every circle has center of circle, right? And you can use this one as you can open your finger and just open, and you have a tangent and normal direction. Okay, normal always pointing inside the curve. Tangent always pointing along the path and is 90 degrees to the normal direction. Yeah. So this one you need to lock first. The understanding have to lock here first. Log in first. So now we are looking the axis on the object. On the object, we no longer use x and y. We use tangent and normal. So normal always pointing inside the curve. And the relationship between tangent and normal is 90 degrees. This one you have to log in first. Yeah? Okay. All right. So the rest you read. Rest you read. Rest you read. Now we go into planar motion. What I mean by planar motion? Okay, this is a plane. This is a plane. Planar motion means the object move in this plane. It do not move out. So it's the normal tangent is always inside this plane. Okay. Okay, tangent, you know what does it mean? So if it's following the motion, the T always following the motion and it's always positive direction. If the object move to the back, the tangent is always follow the motion. It's a bit different from the X and Y just now. The tangent direction is following the object motion and not the global axis. So if object move to the right, means your tangent is positive to the right. If the object move to the left, means the tangent direction positive is to the left. Okay. Okay, normal axis I already have. So you see this as a curve. So you recall back the curve equation. You know that curve equation, when you calculate curve equation, yeah, you still remember this one? How to find S circumference of a section? S equal to R theta, right? Or if you take something from the screen here, how to find the ds? ds equal to rho and the small theta here, right, inside. Okay. Continue. Okay, so if the object moving, you have a small distance that you can measure. The rest you can just ignore. I just want to show you this diagram to show you where is the center of the curve. If the curve is curving inside, the O is this direction. You want to put anywhere is up to your freedom. I don't minus mark if you put any direction. But if you put in the wrong direction, then the whole question is wrong already. Okay, so this side is curving in and this side is curving out. So this one is here. Right? So radius and center of curvature, you have to know. Okay, we start to derive a bit equation. You can ignore it because I just want to show you the equation that you're going to use. Okay, but this part I'll go very fast. Then I will stop at the place where you need to pay attention. In general, if you look at the object and it moves with the velocity, in mathematics, you can write in this form, magnitude and direction, which is in X, global X-axis, you write as the X and I. But if you focus on the object, you can no longer use X and I, you can use tangent and normal. So the yellow color is the magnitude that you are familiar, but now what is new for you is the direction that defined in the tangent direction, and we label as UT. You can see it as I, but I is for global axis, but this one is for the object. So UT. UT is just a direction. It's just a unit for direction. See it as a unit of direction. Okay. And then for the rest of this chapter, if you see a dot above it, means you differentiate with time. If you see a dot, means there's a different, you differentiate it with time. If you see double dot, means you double differentiate it. Right? Okay, so acceleration. So you have v equal to two vector here. One is scalar, one is direction, magnitude and direction. So if you differentiate this term, Ignore this one first. Ignore this one first. If you differentiate this vector form, you need to use chain rules or product rules. So you arrive at this one. I skipped the derivation already. You arrive at this one. So what is acceleration? Acceleration is the time differential of velocity, which is v dot, and v equal to u, v ut. So you use the v dv, that one, uv, differentiate uv, that one. Then you get v dot u dot v dot ut plus v ut dot. Just accept, just accept. Just accept. Just accept. I won't test you on how to derive this equation. I won't ask you to derive this equation. No. You just remember the later one. Okay. Now what is important is A equal to time differentiate of velocity. That's it. What is important is A equal to time differentiate of velocity. This one later, not important at the moment. Okay, so, and then, when you draw a vector diagram, something like this, when you see this one triangular, right? It's a vector, right? Can you write an equation for this vector? If you just look at this triangular, what equal to what plus what? You got three term here, right? U prime equal to ut plus du, right? Dut. So this arrow plus this arrow equal to this arrow, right? This is the origin. So this one plus this one equal to this one. Okay. How do you see a vector triangular? They always a direction. They always a result. So if you have two arrows that is following, that is a member. This following, this is not following. This is contradict. Langgar already cannot. So when you have two member continue, this is a member on the right hand side equation. This one plus this one, right? Equal to how you reach here from here. You need to go through this arrow and this arrow. So the resultant is this arrow. So this arrow is u comma t equal to this one plus this one. Yeah. This one can change. All this term can change. But what is important is how you read the vector diagram. Yeah. Okay. Was in okay. Okay. Hey, break. Okay. I draw this triangular. Okay. So you have this triangular, right? The answer is I put in the notes here. You have 3 points A, B, C. You are moving from A to C. How you reach C from A? How you reach A point, small A point to C? You need to go through A, B, B, C, right? So the result, you have the equation, something plus something, right? This is your process. This side is your process. This is your result. So your result is A to C, right? So this side is C. Process is from A to B. And it's always following, the arrow always following from tail to head and then tail to head. You see the flow or not? So this is the process. So this is A plus B. Yeah. So this is the general things. Okay, we have maybe we have 5 minutes breaks. We continue 12:10. Okay, 12:10 continue.